Lesson 70 is on volume. Remember from lesson 67 that geometric solids are 3D figures that take up space. For example, right down here is a rectangular prism. It's 3D. Volume is the space occupied by a geometric solid. So this rectangular prism takes up space. You can set it on a counter. It's 3D. So let's look at example 1. Example 1 says this rectangular prism was constructed of unit cubes. Its volume is how many cubes? Well, as you can see here, we have 3 layers by 4. So 3 by 4. But we have 3 rows of that. 1 row, 2 rows, 3 rows. So we actually have 3 rows of that. So to find the volume of this cube, we would have to count as many of these little cubes are in here. If we counted them all, we'd have 3 times 3 times 4, which is 9 times 4, 36 little tiny cubes in this rectangular prism. Volumes are measured by using cubes of a standard size. I have a cube down here, and it is a standard size. A cube whose edges are maybe 1 centimeter by 1 centimeter by 1 centimeter. Well, to find the volume of that, we'd have 1 times 1 times 1, length times width times height, and we'd get 1 centimeter cubed. Notice each of them had centimeters. There's 3 different labels, so that's how we get our cubed. Let's take a look at example 2. In example 2, it says find the number of 1 centimeter cubes that can be placed inside a rectangle box with the dimensions shown. So they're asking you how many little tiny cubes are going to fill in to this rectangular prism. To draw this, I would say the base, the bottom level, we're going to need something that's 5 by 4. So this will be the bottom layer that will sit right in here. All right, I've got 1, 2, 3, 4, 5 by 1, 2, 3, 4. So that's going to sit here on our bottom box. But I have 3 rows of these, so that's why I'm going to have another layer that sits on top of that and on top of that. To find how many 1 centimeter cubes will fit in this, we will need to find the volume of this cube. Volume is equal to length times width times height on a rectangular prism. So our length is 5, our width is 4, and our height of our prism is 3. When we multiply this, 5 times 4 is 20, times 3, 2 times 3 is 6, add our 0. So we're going to have 60 1 centimeter cubes. To find and label the area of this cube, then, we have centimeter times centimeter times centimeter, so therefore we have centimeters cubed. In example 3, it says, what is the volume of this cube? They tell us that the dimensions are in inches, so we could label all of these inches. To find this, we're going to take the length, 4 inches, times 4 inches, times 4 inches. Length times width times height. Length, width, height. Therefore, 4 times 4 is 16. Then I still have to take it times this final 4. This is inches squared now. Now, 16 times 4 is 64. I had inches squared times inches, so therefore I now have inches cubed. Example 4, we're asked to find the volume of this solid. It's just like finding the area of a multiple figure. You're going to have to break this up. when you break this apart right at the seam here, it breaks this into half because this is 4 centimeters here, so therefore from here to here is 4 centimeters also. So to find the area of just this bottom part, it would be length times width times height. Okay, length is 8, the width is 4, and the height is also 4. So to find just this bottom piece down here, the volume of that would be 32 times 4, which is 128 centimeters cubed. Now we have this top piece we need to worry about. We have 4 by 4, and remember the width is 4, so this width is 4. So it doesn't look like it, but it is in fact a cube. So to find the area of this cube, our length is 4 times our width is 4 times our height of 4. So therefore we get 16 times 4, which is 64 centimeters cubed. Add the two areas together to get a total area of the entire figure. 128 plus 64. I have 192 centimeters cubed. For your practice, on page 492, I would like for you to do C and F.